Today we're going to talk about the real number properties. A lot of these properties you have learned in previous math classes, but there are a few today that are going to be new. The reason why we have these properties is so we can verify and validate everything that we're doing in math, is allowed for some reason. So you want to make sure you have this piece of paper in front of you. If you don't have this piece of paper in front of you, make sure you pause the video and you make sure you get it out. And because it's our notes, I am going to go ahead and color code like I would if we were in class. So highlight my title. I've used this in previous years and it talks about SOL. We don't need to do that, so you can just cross that out because it doesn't matter. And then I'm also going to highlight where it says goal, because everything we do in this class has a goal, okay? So our goal is to determine which property, if I can spell, which property applies to a given example. So I'm going to go through all of our real number properties, and then you're going to have examples that you can practice identifying it. This is 100% memorization. If you don't memorize this, each of your properties, it makes this a lot more challenging. So you need to be very careful. So below we have 4 different properties we're going to be talking about. And it says below are the real number properties that apply to addition and multiplication. Okay. So these 4 properties apply to have an addition example and have a multiplication example. So I want you to go ahead and I want you to take a second and I want you to highlight the border of this box, all this box. So your brain knows that when you're looking at this as a reference to study them, and I'm even going to go and it stands out. Okay? So I went ahead and I just went in and typed up all of the properties on this page so you don't have to listen to me as I write them down. So we're going to go one by one so you can hopefully easily fill this in. So the first one is the commutative property. So the commutative property, what does it mean? Well, hopefully you remember that with the commutative property, the numbers switch places. So I'm going to write up here, numbers switch places. So if I have an addition example, I could say 3 plus 5, and that's the same thing as saying 5 plus 3. Notice the location of 3 and 5. They're switching around the equal sign. So I'm physically picking them up and I'm flipping them around. Okay? And a multiplication example would be like 3 times 5 equals 5 times 3. Same thing, 3 and 5, they're swapping places. So commutative property, the numbers switch places. What about the associative property, which is the next one? The associative property tells me that parentheses move. A lot of times teachers like to call this as the social. The associative property is social because it looks like the word social is hiding in it. Parentheses like to give numbers hugs. So if I have x plus parenthesis y plus z, y and z are currently giving each other a hug. And since the associative property is social, then x plus y is going to give each other a hug plus z. So notice that the parentheses just move. So y and z are giving each other a hug, and now x and y are giving each other a hug. So they're being social. Everybody is getting a hug. If I were to do multiplication, I would do x times y times z. And notice I didn't put dots because that just means multiplication is invisible. And then I could go ahead and move it and say x, y, z. So one thing I want to notice is I want you to notice that x, y, and z always stay in the exact same location. It's just the parentheses that are moving. So with the commutative property, the numbers switched, but with the associative property, the parentheses switch. If we go down and we do the identity property is just based, whenever you look in a mirror, you see yourself. You see your own identity. That's who you are. So your identity property is the end result. The end result is what you started with. When I go and I look in the mirror, I see myself. I don't see anybody else. I start with myself and I see the result as myself. So if we think about an example, we'll use the number 3. What do I have to add to 3 to end up with 3? Because I have to start and end with the same thing. So what do I have to add to 3 to get 3? Well, 0. So that's an example of the identity property. And if I start with 3, what do I have to multiply by 3 to get 3? I don't want to multiply by 0 because then that's 0. So 3 times 1. So the identity property, I'm adding 0 or I'm multiplying by 1. And if we go ahead and we also do the inverse property, when you hear the word inverse, okay, we're going to be using this property a lot because the inverse in math is huge. Everything has an inverse. So if I were to ask you right now, what's the inverse of up? Hopefully you're thinking down. What's the inverse of happy? Sad. Okay, so what does that mean? If you had to use a different word other than inverse, what would you say? Hopefully you're saying the opposite, because that's what it is. The inverse property is the opposite. Okay, or you can also say the reciprocal, and we'll talk about that with multiplication. Reciprocal. I spelled that wrong. Hold on a second. Reciprocal. So, if I start with 3, 3 plus the opposite of 3. What's the opposite of 3? Negative 3. So 3 plus negative 3. What's 3 plus negative 3? 0. And then 3 times something is going to equal something. So with adding, I think the opposite of 3 is negative 3. The opposite of 5 is negative 5. The opposite of negative 7 is positive 7. That's with the addition. I think of the opposite. With multiplication, I think the reciprocal, which means I have to make it a fraction. So 3 times 1 over 3. So this looks like 3 over 1. The reciprocal as I flip it, so it'd be 1 over 3. That's going to equal 1. So notice, and if I put this in red too, notice my identity property is what it equals. So I added 0. For inverse, it ends with 0. With multiplication, I multiply by 1, it ends with 1. So another little helpful trick that I do with this is whenever I see a fraction, I think about the inverse. So has a fraction. It's another good, cute way to remember it. Okay? So hopefully you've gotten all of this, and if not, fortunately, you can pause it at any point. I want you to go down and I want you to try these examples on your own. So I want you to pause this video, and I want you to try these 7 examples on your own, and then unpause the video, and I will go over the answers. So if I look example 1, 9 plus 7 equals 7 plus 9. That is the commutative property. And you can just write prop for property, and then it's of addition, because there's plus signs. T plus 0 equals t. So I start and end with t. That's the identity property. And that's the identity property of multiplication, of addition. And again, you could call that the additive identity if you wanted to. That's totally fine. So number 3 says 3 times x times 5 equals 3 times x times 5. So I notice the parentheses are moving, so everybody's getting a hug. So that's the associative property because it's very social. And this is the associative of multiplication. So I'm just going to use a dot for multiplication. All right, let's look at number 4. 1 times m equals m. Well, that's the identity property. So I can call this the multiplicative identity. Or I can call this the identity property of multiplication. It really doesn't matter. Number 5, 3 plus negative 3 equals 0. Well, 3 and negative 3 are opposites, so that's the inverse property. And I can call this the additive inverse, or I can just say inverse property of addition, because there's plus signs. x4 equals 4x. So what operation is hiding between x and 4? Multiplication. So it's x times 4 equals 4 times x. So notice those switch places. So that's the commutative property of multiplication. Number 7, I immediately see it has a fraction, so I instantly think it's the inverse property. But if I look closely, they are inverse, they're reciprocals of each other. So this is the inverse property of multiplication. So hopefully you're okay with that. I have two more examples I want you to try. So we're going to do 8, and we're going to do, I'm going to write, hold on one second. So I wrote down the problem for you to do. So try this one. I'm just going to make you do 1, not 2. So try this one, pause it, unless you want to just, if you can instantly see it. Which property is it? Well, notice parentheses didn't change who they're giving hugs to, but that this and this switched places, right? So what property deals with switching? Commutative. Of addition. Go ahead and flip your paper. So with this one, you can go ahead and you can cross out this bottom one. We're not going to use that. Okay? And so we're going to look up at these ones. And these properties don't only work with multiplication and addition because they might have them both in them. So go ahead and highlight the border of your box for me, just like we did on the other side. So I went ahead and I highlighted all of my boxes, and I also wrote down all of the properties that are on this page. So notice we have 5 properties, not 6. I have 1 extra row on this one. So these properties on the back don't only apply with addition and multiplication separately. Some of them have multiplication in them with addition or not, or it's just one or the other. So first we're going to talk about the distributive property. The distributive property, hopefully you all know because we talked about it last class with combining like terms, but the distributive property I always says starts with parentheses and gets rid of them. So it's always starting with parentheses and then getting rid of the parentheses. So if I look at an example, I would do 2 times 4x plus 3. So that's going to equal, I can distribute it. 2 times 4x is 8x, and 2 times positive 3 is 6. So it starts with parentheses and then gets rid of them. So that's the distributive property. The multiplication property of 0 is exactly what it sounds like. So the multiplication property of 0, anything times 0 equals 0. That's what the multiplication property is. So if I have 3xyzw times 0, that's going to equal 0. Hopefully that's your favorite one because that's the easiest one. So now if we talk about the last 3. These last 3 properties you've never learned before. So I want you to go ahead and highlight them in a different color, or I want you to put stars by them, or whatever you're going to do, because since these are the new ones, they're going to be the ones that you are most likely to forget. So let's talk about the reflexive property. The reflexive property is the most pointless property. I call it the common sense property. You really don't need to know it, or don't need to have it written as a property because it's something that you can already basically assume. So I call this the pointless property. But it has a point because everything we do in math, we have to be able to justify, right? And if we're not able to justify it, then makes life a little bit challenging. So the pointless property, why it's the pointless? Because it does nothing. It does absolutely nothing. If I have 3 plus 2, that just equals 3 plus 2. Yep, notice nothing changed. 3 plus 2, 3 plus 2, nothing changed, nothing happened. It seems pointless. It's the reflexive property. Okay? Symmetric property. Symmetric property is a lot like the commutative property. The commutative property did what? It switched my numbers, right? So the symmetric property switches my numbers, but the commutative property switched around pluses and times, pluses and multiplication sign. The symmetric property says the following. If x equals 12, then 12 equals x. Oh, and I just wrote that in the example spot, so that should be over here. And then we'll write the meaning here in a second. We'll just flip those two boxes. Sorry about that. If x equals 12, then 12 equals x. So notice what's happening with your numbers. They're switching, right? But what operation are they switching around? Well, they're switching around an equal sign. So the symmetric property swaps around an equal sign. Not too terrible. So symmetric is a lot like symmetric is a lot like the commutative property. And last but not least, we're going to talk about the transitive property. The transitive property always has 3 parts. Okay? It has the word if, it has the word and it has the word then. So, here's what the transitive property says. If x equals b and b equals 7, then what? If x equals b and if b equals 7, well, what can I conclude then? X equals 7, right? Because if x and b are the same and b equals 7, so since b equals 7, doesn't x also have to be 7? Yes. And if you notice b is used twice, you slice out the middleman. My answer is, what's left? X equals 7. So the transitive property is the weirdest word. It has the most parts. It has the word if, it has the word and it has the word then. Okay? So, if we scroll all that fun stuff, so we don't have to, we can now look at these examples. I want you to go ahead, I want you to pause this video, and I want you to try examples 1 through 6. However, I want you to cross out number 4 for me, please. I want to cross out number 4. Okay? So do 1 through 6, and then unpause the video, and I will go over the answers. So we look at number 1. 4 times the quantity of x plus 2 equals 4x plus 8. Notice I start with parentheses, and then I get rid of them. That's the distributive property. X plus 3 plus y equals x plus 3 plus y. Did anything change? No. So, reflexive property. The pointless property. Woo! Number 3. If x equals 3, then 3 equals x. Notice what's happening with x and 3. They're swapping around an equal sign, so it's symmetric property. Number 5 says negative 6p times 0 equals 0. This is the multiplication property of 0. Number 6 says if x equals 3 and y equals 3. Oh, sorry, that's a typo, but hopefully you figured it out because it had 3 parts. We're supposed to say if x equals 3 and 3. I'm sorry. It's supposed to say if x equals y and y equals 3, then x equals 3. Notice your middlemen get canceled out. I'm left with x and 3, so that's my conclusion. So this is the transitive property. So if I reiterate one last time, the most important part about this unit or this part of the unit is that you have to memorize these words. If you don't memorize them, it makes this 20 times harder. So make sure you memorize them and then you should be golden.